Programming. Here's the actual programming part of the project. And now that we've actually gone over the theory, I'm very excited to go ahead and explain how we're actually going to program our first CNN model that can classify flowers. And so this is also a tutorial that is available on the official TensorFlow website if you'd like to go view the code. But the actual exercise that you'll be completing this section is typing up the code as I go through these modules and explain it. So let me just go ahead and give a quick demo of Google Collaboratory. And so if you go to your Google Drive, if you click on that plus icon, and you can scroll down and you can see that there's an option called Google Collaboratory. I've clicked on that and I click New Notebook, and you will have something that basically looks like this. You'll only have this box right here. For example, let me show you actually what a new notebook looks like when I open it. So you you guys are gonna have something that basically looks like this. Here's the name of the file. You can choose whatever name you want. And actually, if you click on runtime right here, if you click on change runtime type, most of you will not have any hardware accelerator turned on. However, you can choose to have a GPU or TPU. Now, if you're going to choose a TPU, there's some code that you have to include. And so I'm just going to go ahead and use a GPU in the example. So if you click on GPU, that essentially just makes the process much faster because GPUs are much better, one for memory, but also for matrix operations, which is what these convolutional neural networks do. And so I'm just going to click cancel because it's an example notebook. But how Google Collaboratory works is essentially, you have sequential Python coding. And so here, for example, you can write some Python code, and that will, if you click this run button, it runs it and it saves it in memory. And if you say something like print last statement, it's going to say like print some Python code. That's going to be the output. And so that's not a great example, but the idea is just that basically, let me just go ahead and write it out. X is equal to hello. If I go here and I say, if I run this piece of code right here, it just takes a while to set up initially. All right, so X is assigned to hello, print X, and we have X saved in memory, and now we can add code in below to do some with X or whatever variables we need. And so that's basically how Google Collaboratory works. Now let's actually go back to the machine learning example that we were starting with. And so here is a Google Collaboratory notebook that has some text associated with it if you'd like to go through it as I'm scrolling down. But essentially here is the first actual code statement. And we're going to be downloading what's called the TensorFlow Lite Model Maker. So TensorFlow is the machine learning library that's widely used. And this is now we're just installing basically a file that we'll need for this process. But TensorFlow basically does all the operations that we studied before: convolutions, pooling, padding, dataset pre-processing. It does that all for us. And so when this is finished, we'll get a nice little check mark. Again, it's just setting up some of the wheel and Python files that we'll need. But let me go ahead and explain the next part of it, which is actually just the imports. And so if you've used Python before, you know that we just need imports for certain libraries. These are the libraries that we're using. We're just making sure here that we're using TensorFlow version 2, because as of the moment of recording this video, that is the at least latest version of TensorFlow. And so if you click right here and you run it, we will have each of these libraries imported, and then we'll get a check mark when we're finished. And so we see that we're done right here. We scroll down, and right here is actually where stuff starts to get a little bit more familiar. And so we're actually downloading a built-in TensorFlow library that is called Flower Photos. And so if you go to this link right here, it's a zip file. You can download it, but we're going to download it right into the Colab environment. And so I'm just going to go ahead and click image path to set it equal to this library right here, and it downloads the data for us, and it saves it into this environment. And so essentially, if you remember, we talked about in the very first lesson how you create your own data set and you have your images. Here, this is a TensorFlow built-in library, so it has all of the images and the associated labels with it as well. And so if we keep going down, basically these just kind of detail, you can look at the text, but I'm just basically explaining it as I go. And so if you look at right over here, this is the actual image processing step which we went over. And so we have a built-in function called data loader that essentially takes the image path that we assigned. And so it takes all of these photos and labels and basically pre-processes it for us. It converts it into that 0 to 1 format. And then if you remember here, we talked about training data, testing data, and validation data. So this data set is too small. Actually, it's about 3,600 images. In fact, here are labels. I'm just going to go ahead and run this. It might take a little bit, but essentially here's the image processing step. And then here's the training and testing data set. And so if you saw in the previous output, we only have about 5 labels and only 3,000 images. And in the machine learning world, 3,000 images isn't that much. And so we're only going to have a training data set and we're going to have a testing data set. And we're only going to use the training data in the training phase. At the very end, we're going to test them all on the test data set to see how it does. And so basically what the data split here means is that we have the value 0.9, which means that 90% of the data goes to training and the remaining goes to test. And so 10% will go to test. And this data loader here basically, again, takes all of the pixels, minimizes them, and saves them. And this here is just splitting up the data. So now that we actually have the data set, let's create our model. And so here's the convolutional neural network architecture. And in TensorFlow, it's so simple. You just have image classifier.create, and you have your training data that you're going to train. You just feed it into the model, and we're basically good to go. And so the model will basically create itself, and it's as you can see here, it's just starting the training process, I believe. And here's actually a little bit of info about the model. And so you can see actually here it started to train, which is interesting. I believe that the image classifier model actually starts training automatically. So you can see here actually that we have an accuracy measure and a loss measure. And so we didn't cover loss, but we did kind of cover accuracy. So what's going on now is that the model is being trained on the images that it sees of tulips, roses, etc. And then it's actually checking based its prediction on the label. And so we can see right now it has a 78% accuracy and it's been trained. But actually one thing to know is just that if I clicked on the model, but it doesn't really give you that much. And so dropout on dense layers, don't worry about dropout. That's a little outside of the scope of this course. But the dense layer is actually the prediction layer. And so we have 5 labels. That's why you see this number 5 actually. But this is the main layer of the model. That's a convolutional neural network layer. And so I searched up model.summary because that's a function you can do. When I searched up model.summary, this is what I got, which doesn't give you a lot more. But normally if you click model.summary, you'll get something that looks like this. And these are the layers in our model. So we have an input layer, which is our data layer, and then we have our convolution layers, which I talked about. So basically, these are the filter layers, and then we feed into a pooling layer to minimize our data, and then we do some dropout, which is a little outside of the scope of this course, but then we do convolution layers, and then pooling. So you can see actually, this is the exact process we talk about, and that's kind of what it looks like. That's what's going on here. So like I mentioned at the very start, epochs or epochs are the training durations, and you can see that the accuracy is increasing. The model, the hidden layers are becoming better fine-tuned, and the accuracy is increasing, and we're on the last epoch, and because we're in a GPU, it runs very quickly. And so we're actually done with training. We get a 93% accuracy, which is very good. And so it might differ for you because each mathematical operation is different. You can increase the number of epochs that you're training for. You can train the model again. Just click this button and it'll train it again for you. And so let's actually evaluate this model on the test data. So if we click right here to see how it does in a completely new data set, we're gonna give the model a minute and we see, okay, it got an 86% accuracy. That's pretty good. It's really trained for 5 epochs, and so we'll go with that. And then right over here are just the export steps. So we're gonna save this model as .tflite, and in the next step we're actually gonna go to Android, and I'm gonna show you guys how to deploy this model there. Thanks for watching.